Let's do a quick recap. All right. We learned about normal distribution last week. Correct? We learned about normal distribution, and the area under the graph will always be total area under this probability density function must always be equals to, all look up, don't talk, must be equals to 1. All those late is not because your tutor release you all late, because you all cannot walk faster. Right? Total area must be equals to 1. Okay, you have some blank pages at the back. I need you all to just answer these 3 questions for me. Now, suppose X belongs to a binomial normal distribution. Can we quickly sit down and slide 1? A, what? B, A. Okay, copy this question down. You have some blank pages at the back. I need you all to answer these 3 questions. 1. Can we quickly use GC, find the probability X quickly? Sorry, my bad. Ayo, you all never tell me, I write for nothing. Ayo. Total area 1. Quickly, using GC, what is the probability that X greater than 165? This is, X is the height of, suppose X is the height of a randomly chosen student. Correct? With mean, this is the mean. Can I have attention, please? Very quickly, I need you all to find an answer. I'm going to walk around. I'm going to check on your answer. Everybody must have answered. Pointer, I didn't bring my pointer. Come. Yeah. Quiet, let's talk. Let's go. Copy this. See. Yeah. I know. Tell your tutor next time, okay. Alright. Visitor. A visitor from Japanese school. Welcome, Ted. Best next lecture in EJC. Okay, quickly come. Let's answer this question. We're using GC. Don't talk. Hurry up. Answer. Who got answer? By using... Shh. Have attention, please. Look up. If you talk, I will ask you for your answer. Do we all know? Yes? By using GC, you should be able to find the area under the curve, 5. You should be able to find this area. By GC, answer is 0.266. Next question. Hence, without using GC, what is the probability of X greater or equal to 265? What's the answer? without using GC. No need to type again. What's the answer? Same. Very good. Why is it the same? Because whether it's greater than or greater or equals to, it doesn't make a difference. Now, I'm not quite sure whether we all understood why. I don't know whether you recall what I said was this. Sorry, just give me a minute. For continuous random variable, probability x equals to x is always 0. That means it can be 1.65, it can be 1.66. Now, can you have attention please? Do we actually know why? I explain one more time, okay? Probability x equals to a specific value for a continuous random variable will always be 0. The reason is this. Do we all agree for a continuous random variable, there are infinitely many different x? It can be 1.6, 5, 2, 3, 1, 0, 0, 0, 8, 5, 4, 3, a lot of different values. Can you imagine if probability x equals to 1.600000123, say equals to 0.00001. If it's this value, can you imagine there's one value? Then the probability x equals another value is another this value. How many values do you have here? You have infinitely many. Then you take infinitely many, multiply by 0.001, you will get more than 1. You will net, because total area must be equal to 1. So you all get the idea. So therefore, this answer must definitely be 0.266. It should be the same. Last one. Without using GC, state the probability x smaller than 155. What's the answer? Is it also the same? Yes, because this graph is symmetrical about 160. Got it? That makes sense? It should still be the same. So answer to all three is still 0.266. Can? Okay, good. Let's start with, sorry, not this. This one is later tutorial one. Okay, now, we stopped here. Part 3 of example 1. What if the question asks, okay, thank you, for a range. Now the GC is well capable of this. Can I have attention? The GC is well capable of this. You just need to enter your lower. It's driving me nuts. Sorry, I don't know why this thing is always like that. Yeah. You just need to enter this as lower, this as upper. You should be able to get your answer. If you are fast enough, you just quickly enter in your GC and then you will get this answer. Got it? Questions? Easy, right? Good? Okay. Just a few notes for us to see. Does this make sense? Total area under the curve. This is 20. This is 18. This is 22. Does it make sense that x greater than 22, which is here, plus x between 18 and 22, plus x smaller than 18 must always be equals to 1. This is total. Of course. Yes? The rest I don't want to go through. Now next, example 2. Now in example 1, you are asked to find probability. That means area under the curve. Make sense? Now what if they ask it in a reverse way? What do I mean by reverse way? Let's take a look at this question. Question 2 part 1. You are given that probability x smaller than a. For some a is equals to 0.8. Now you are given an area. You are given a probability. The question asks us to find this answer. Now, this value, how do you obtain it from GC? You can try and error, but I don't think you want to. Alright? And you try error until a long time. Now I see some people sleeping. Can you wake your friends up? Yes, Tobias. Wake your friend up. Okay? Now, how do we obtain this value from GC? Now, instead of using normal CDF, you use inverse norm. Now, the keystrokes are all in your notes. You use inverse norm. So let us do it together. All right. Second, VRS, inverse norm. Right, inverse norm. Now, some of us may see this thing, may not see this thing. Never mind, it's okay. I will explain to you. Okay, if you don't see this thing, just ignore what I say. All right. If you see this thing, just put the tail as left. I will explain what is left later. So you enter area as 0.8 because you want area to be 0.8. The mean is 20. The standard deviation is root 5, not 5 because you want to enter standard deviation. Can I caution all of us? If you see this screen, can you please remember to close your bracket? Otherwise, you will get an error. Then you put left, enter. What this is doing is you tell the GC that I want area 0.8. This is your left area. Because this is a left bound area from A. Does it make sense? Does it make sense? Yes? You are telling us the GC, I want a left area, anything to the left of A, I want it to be 0.8. I inverse norm, I will get my answer 21.822. Answer is, you got 21.822 from GC, therefore A is 21.9. Can I just say, from here to here, you just round off. Don't think so much. If it's 21.88, you round off to 21.9. If it's 21.82, you round off to 21.8. Just round off. Don't think so much. Got it? Understand or don't understand? Good. Later I explain this one. I'll explain this one later. Okay? But for those of us who don't see this screen, can I have attention? For those of us who don't see this screen, you must always enter the left bound area. Never mind, I'll explain later. For part 2, let us see what happens in part 2. Look up. Look at my diagram. The question asks, find A such that probability x greater than A is 0.75. A bit too noisy. Thank you. Good. If you want to come in and play with your phone, then I suggest don't come in. Oh. You want to find area such that the right bound area is 0.75. And you want to find this A. A diagram is always useful. A cumulative density function is always useful. So how do we find this? Do we inverse norm and then enter 0.75? No, we can't. Because the question always, the GC can only work with here. This one will always be, if you see this one, if it's not, it's always left. So I would first do this. I would first say, if this is 0.7, I better use a different color, the blue color. I would say probability x smaller than A must be equal to 0.75. 0.25. I will convert it into a lower bound area first. Then this is 0.25. I want this to be 0.25. Only then can I use GC here. Look. Only then can I use GC. Then you enter the same thing. Alright? And then from GC, you enter this, you will get A equals to 18.5. I'm just very quickly going to show some of us who has the new OS, who can actually see the left center right one, to see how you can obtain it without doing this. Okay, if you have new GC or new OS, you can skip this. You can skip this step if you have new GC. How? Can I show all of us once? Then I don't want to say too much. You will enter 0.75 here, and then you will use your right area, because you're telling yourself, you're telling GC, that you want right area to be 0.75. You will still get 18.5. Got it? Got it? Good? Questions? Good. Example 2/3. What if, thank you. Can you have attention, please? A bit too much talking. I don't need to talk so much already. All look up. What if you are given this and you are required to find area? Sorry, you are required to find A. A diagram is very useful. I will first draw a diagram and say I want area to be area between A and 27 to be 0.234, which means this idea, I need this. I want here this area to be 0.234. I want A between A and 27 because mean is 20 ma. A diagram is useful. Do we have this? Yes, can we copy? You have? Not in the notes, right? I say it one more time. In blue, that means not in your notes. Better copy. You are trying to find what is the value of A. Now, GC cannot give you the answer immediately. Right? The GC can only tell you what is the value of A if you give it the lower bound area or the upper bound area. So how do you do it? Okay. You want this area, this sandwich area to be 0.234. Now this area must be x smaller than 27 minus x smaller than 8. Does it make sense? What I'm saying is this area, I can rewrite it. This is probability x smaller 27 minus probability x smaller than 8. Does it make sense? You look at the diagram and this thing should make sense. The sandwich area is just x smaller than 27 minus x smaller than 8. Now I think with that, we know how to carry on. Why? This one is just a number, don't need to be scared. Correct? Yes? Nothing to be scared. So you have probability x smaller than A. What I will do is, I bring this over, calculate, blah, 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 by GC. This must be equals to 0. This is 0.99913. Okay, so must be equals to 0.99913 minus 0.234. Okay, by GC, this thing is by GC from here. This to this is by GC. Okay, you know how to get, I don't want to go through. Right? You just normal CDF. normal CDF. Which means now I need my upper bound area, lower bound area, probability X smaller than A, you will get 0.76513. Just take note, can we make sure that this one, your intermediate step must be 5 SF? Okay, 30 seconds, find A. Okay, inverse norm. Okay, if you press your calculator fast enough, I don't think it's a big problem. By GC, you just immediately by GC, you can say that A is 21. A is 21.6 VSF. Okay, you just round off to 21.6, done. Got it? Okay? Good. Let's move on. Recall the last part of the problem, don't need to copy. Now, you want the range of values of A. Let's take note here. Pay attention. This is not an equal sign. Now there's the double inequality here. You need the range of values of A for which X greater or equal to A is greater than 0.9. Wow. Some of us may find it a bit difficult. Right? Some of us may find it difficult. Never mind, it's okay. Let's solve it like that. Again, I say a diagram is super useful. Now what we are trying to do is this. What if this is equal sign? If this is equal sign, we can change. If this is equal sign. Okay, if this is equal sign, we solve it, we find that A is equal to 14.8. Not yet, not done yet. What we are saying is, if this is 14.8, probability X greater or equals to 14.8 is equal to 0.8. Now, shall we take note? This now we want to solve for, you want an area, you want area to the right of A to be greater than 0.99. Do you think, let's think carefully together, do we all think now A should be less than 14.8 or A should be greater than 14.8? You want the right bound area to be bigger than 0.9. Should be less than, right? A therefore should be less than 14.8. Now we must always think like that. Don't memorize. Don't even attempt to memorize. You must always draw your curve, normal curve, and then look like this and say that this is 0.99. In order for the area to be greater than 0.99, your A must be less than 14.8. Got it? So therefore, answer you need imply A must be less than 14. Okay? Just like that. Just looking at the graph. You must infer this from the graph. This is got it? Good.